Hello students, welcome to my channel Infinity Minds where maths is made easy. Today we shall be doing question number 3, 4 and 5 of page 94, figure it out. We are continuing with the chapter Quadrilaterals of Ganita Prakash-I. Question number 3 says, consider a circle with center O. Line segments PL and AM are two perpendicular diameters of the circle. What is the figure APML? Reason and or experiment to figure this out. Okay, so it basically talks about there is a circle with center O, lines PL and AM. M has got misprinted, yes. PL and AM are two diameters. Diameter, children, let me just recall quick diameter, the definition of diameter with you quickly. It is the longest chord in a circle. Chord means line segment having its endpoints on the boundary of the circle. Chord in such a way that it passes through the center of the circle. It passes through. Put the tip of the compass, open it, that is your radius, and you draw a circle. The point where you put the tip of the compass is your center. A line segment that has its endpoints lying on the boundary of the circle, but it passes in such a way that it passes through the center of the circle. PL is also a segment having its endpoints. AM is also a segment having its endpoints on the circumference, and they are passing through the center. A diameter of a circle is twice the radius. What radius have you chosen? Twice of that will always come out to be diameter. So it is asking you as to what figure is AMPL. See, of course, it is a quadrilateral. That is obvious. It is a four-sided quadrilateral. And even if you look at it, many of you may be able to answer that it is a square. Okay. And someone may think on the lines that why can it be a rhombus also, or is it both? So that much is clear. It is something around this. Of course, it's not a trapezium or kite or what. So our reasoning is around this. First of all, you should be clear as to what it is. And secondly, there has to be some valid reason for it. For either of the thing. For either of the facts, what is it and why is it so? Okay. It looks like, yes, that is a very non-mathematical reason. That is your personal perspective. Yes, it does look like. So the answer goes, it is a square, children. But then what reason? What all associates to be for a quadrilateral? What all is needed to fit for itself to be a square? Sides to be of equal length. As of it is not valid. But yes, probably you could measure in your diagram and write that, okay, I'm obtaining a square of so and so size. Square of side 5 centimeters each or something like that, 4 centimeter. That could be one valid reason. That is one way. The best and easiest way is when we are talking of these diameter and perpendicular diameters they are talking about. They are also telling you that perpendicular diameters have been made. What are these diameters? These diameters are nothing else but they are playing the role of diagonals for you. For the quadrilateral, they are playing the roles of diagonals, and your diagonals are perpendicular. They were already told to be perpendicular. What property do we know for diagonals of a square? That they are perpendicular bisectors. Okay. Diagonals of a square are equal and perpendicular bisectors. So equal because they are diameters. So both are diameters. Perpendicular is already given. What about bisectors? Yes, the point of intersection is bisecting them into radii. So of course that's a valid reason. Okay, let's go through the answer slide. In the given figure, PL and AM are two perpendicular diameters of the circle. Let R be the radius of the circle. Since PL is equal to R plus R, 2R, and so is AM. So PL is equal to AM or equals to 2R equals to diameter. Yes. Okay. Next, PL and AM are equal. So we proved them to be equal. They are perpendicular and each of the part is equal to radius. That is, they bisect. So all these qualify to be a square after all. When diagonals are equal, they bisect their perpendicular, so it's a square. Clear? Going to question number 4. We have seen how to get 90 degrees using paper folding. Both of these questions, children, the last two questions of the exercise, question 4 and 5, are not, question 3 and 3, 4, 5, all three are those kinds where next to them it is written maths, talk or discussion, okay? They are more for your discussion, for your understanding. Maybe a direct question can't be picked up, a heavy question can't be expected, but yes, somewhere a knowledge of it or a fill in the blank or some part of it could be asked. They are more for knowledge and discussion. Okay, anyways, coming to question 4. So I have discussed all the answers in detail so that your knowledge is complete. Rest, how it gets applied, that you could see. This is like more of a sort of an activity. If you work it out yourself with these things, you will understand further better. Anyways, let me just let you know how it goes. We have seen how to get 90 degrees using paper folding. That is basically any paper which is folded. So they are trying to tell you that that's a 90 degree. Now suppose we don't have any paper, but we have two sticks of equal length. Let AB and CD be two sticks of equal length. Here AB and CD are the two sticks that we are talking about, are of equal length, okay? And a thread. How do we make an exact 90 degrees using this? You have two sticks. So how do we make a 90 degree? Okay. Mark the midpoints of the sticks using a ruler. Fix a screw to the sticks at their midpoints. So at point M, you are fixing a screw. Using a thread, measure distances AD and BD. Keep on moving the sticks about the screw so that the distances become equal. Now see, what needs to be done mainly in the question is, these are two sticks of equal length. You fixed a nut bolt, a screw in such a way that it can be rotated also. And first of all, the thread has been tied, and so that you can measure the length of the thread. Now the point is that you move your sticks in such a way in this direction. As you can see, this is an acute angle less than 90. So let me move it in such a way as I will move it. So I need to rotate my stick CD. As MD will go in the anti-clockwise direction, so will MC. This CM also would move. Try to visualize. As this will go, they will take a shape like this. Point D shall come here, point C will come here. We want to rotate CD in such a way that it should become perpendicular to AB, because you have to get a 90 degrees. Assuming they are inclined at any angle, so now we are rotating. Keep on moving the sticks so that the distances become equal but obvious. So how to obtain 90 degree? It is the length of the thread that we are trying to say should come out to be equal. Okay, because here BD and AD are different. In this position, fix the sticks by tightening the screw. The new position of the sticks are shown. So as we have seen, so this stick, it was like this, it has visualized and come here. Now we wish to have these two to be equal. If we have these two, see, it is asking you to make a 90 degree. Yes, you will try to do that. Approximate. How will you make sure that it is done? It is like a reason, it's like a logic which is expected, a cross check. You have made, how is that possible? Provided the distance which you have create with the thread becomes equal. The ADBD which were unequal, now we expect them to be equal. Their equality shall prove the angle to be 90 degree, vice versa. That is how we are trying to say. Okay, after all, it's a very simple, I mean, it's a kind of a question which is not so possible to be answered as such. So that is why I'm trying to let you know. So we fix. Consider trying, now mathematically going, consider these two triangles. AM is equal to BM was in a way given because we fixed it at the midpoint. AD is equal to BD, that we will make sure, and MD is common. So by SSS, the two triangles are congruent, and CPCT, if I name them, I can have angle 1 equal to angle 2. But also angle 1 plus 2 forms a linear pair. That means each is 90 degree. Securing the lengths of the threads to be equal is helping you prove making sure the angles are right angle. Making sure the sticks are inclined at right angle. Just by looking, and like in the previous question, just by looking, it wasn't clear that a circle determines how to make sure that those diameters were making sure to be a square and so on. So it is, of course, you will try to fix A, B and C, D. Understanding the question is quite a challenge out here, that how will you make sure? So fixing the length, that we rotate in such a way that the threads become equal in length. That will help us to see, make sure angles are 90 degrees. The sticks are inclined at right angle. How come? By using mathematical proof SSS. We are saying the threads are equal. This is a common line and these two are already given to be equal. We started with fixing the screw at the midpoint. So SSS triangles are congruent. CPCT, these two are going to be equal. But together they form a linear pair. Together is going to be 180 degrees. That means each would be 90. It would be 90 each, getting them to be added to 180 degrees. Okay. It's slightly different in answering. Kindly go through the video once again. I hope it is clear. Let us now move to question number 5. This is an easy question. We saw that one of the properties of a rectangle is that its opposite sides are parallel. Can this be chosen as a definition of rectangle? In other words, is every quadrilateral that has opposite sides parallel and equal a rectangle? ABCD be a quadrilateral in which opposite sides are parallel and equal. This is B. So your ABCD is a quadrilateral in which opposite sides are parallel equal. That is, AB is parallel to CD. AD is parallel to BC. Opposite sides parallel. Also they are equal. AB equals CD. AD equals BC. In a quadrilateral, opposite sides are equal. For ABCD to be a rectangle, we require each angle to be 90 degrees also. The given information that opposite sides are just being parallel and equal is not sufficient for something to be a rectangle. For something to be a rectangle, the angle should also be 90 degrees. So this is not a sufficient, as it can't be taken as a definition, core definition. The 90 degree fact doesn't get satisfied, doesn't get guaranteed, ABCD may not be a rectangle. A rectangle cannot be defined as a quadrilateral with parallel equal opposite parallel sides. Those conditions are satisfied, they are necessary, or okay, they are required, but they aren't essential for making something to be a rectangle. For something to be a rectangle, we must be told that even if we are told one angle is 90, or then it can be done. For example, if one angle is told, and of course if angles are given to be 90 degrees. Okay, clear? So this isn't a sufficient condition. So with that, we come to the end of this particular exercise. Thank you for watching. Do like and subscribe to my channel for more informative videos. Thank you. Keep practicing.